Okay, so we're continuing with 1.7 today, where we're going to talk about different transformations of functions. So you guys just read through and you learned about the books in Hannah's home library. Okay, so it's described by this equation, n of x equals 4x plus 2, and it says x is the number of months, okay, that have passed since she began expanding her library. We're going to have to describe how this function is related to the parent function, which we did yesterday. And then we're also going to have to interpret the function in the context of the situation. Okay, one other thing that we should make note of is what your equation represents. So it tells you the number of books in her home library can be described by. So keep in mind this is representing the number of books in Hannah's home library. That is the n of x for your output. Okay, so if we're going to compare this to the parent function, we're going to take a look at this and we're going to say, oh yeah, that's a linear function, right? If it's a linear, we know that a linear function is y equals x, or we can also say, if we want to keep it in form with this, we can say n of x equals x. So when we're doing the first step where we are describing what is happening, we're going to look at these values and we're going to think about how they affect the graph. Okay, so I'm just going to write that over here. You can write it above as well. So anytime we're looking at the transformations, we're looking at what additional values this has. So the graph of n of x equals x is, so we have this 4 in front. So we have to say what that is. Do you guys remember from yesterday what type of transformation this 4 is? Yeah, it is a dilation. It's a vertical stretch, yeah. And then when we do this with a story problem, we're going to say what the vertical stretch is. So nice job. It is vertically stretched. And this is by 4. So if it's a vertical stretch, it's always the number that you see there. Okay, so it's vertically stretched by 4 and is, and then this plus 2 at the end. If it's linear, you're never going to have parentheses. So whatever is added to the end or subtracted is going to be an up or down. So we're going to say is translated 2 units up. Okay, so that's the first part of this question. We have a 2-part question. Describe how it's related to the parent function. So we're identifying the parent function, saying what happened, and now we're going to interpret the function in context of the situation. So whenever you have a linear function, the 2 important things we have are the slope and the y-intercept. And so we're going to have to say how those affect this situation here. So I want you to think about in the context. What does that 4 mean in this situation? What does the 2 mean in that situation? So let's just think about that for a moment. Okay, and I think the y-intercept is going to be a little bit easier. So does anybody want to share what they think the y-intercept represents for this? Exactly. Hannah starts with 2 books in her collection, right? And then the slope represents, what's the 4 mean? Yeah, it's going up by 4. What does that mean in this context? Yes, 4 more books each month, right? Because X is the amount of months. Okay, so we're going to start off just saying exactly what you said. Hannah starts her collection And you can say her book collection is fine, or you can just say collection here. So Hannah starts her collection with 2 books. And adds 4 books. You can say per month, you can say each month, okay, but you do have to take into account the timeline because it's 4 times X. Okay, so you're multiplying the X is the number of months. Okay, nice. All right, so for part B, let's do the same thing. So I'll give you a moment to read through so you know what the situation is about. Let's highlight our key terms. And then let's take it a step further. Let's see if you can just do the transformations, and then I'll help you with the context, because this one, the context is kind of hard to know what they want for this one, so I'll help you with that, okay? All right, let's see how we did here. Okay, so the height and feet of an object dropped from a platform is described by this equation. H of x equals negative 16x squared plus 80. And again, they tell us what x represents. So x is going to be the time that has passed in seconds. And then the height of the object is what the h of x is. Okay, so that's going to be your output of your function. And then again, we're describing how it's related to the parent function, which I'm confident you guys can do well. And then I'm going to help you with this part since that's going to be new for us. So again, we're just looking at this equation here. We're looking at this equation. You have the negative 16 on the outside and you have the plus 80. So we should start by saying h of x equals, and then this is the quadratic, so h of x equals x squared is, and remember the negative means something itself. If the negative is not inside parentheses, it's outside, so that means it is reflected over which axis? The x, because remember XOXO, it's outside, so it's reflected over the x-axis. Okay, the order that I'm writing these in does not matter, so if you didn't say this first, if you said that somewhere else, that's okay. And then the 16, there's no parentheses here, so that is also like on the outside, so we know it's a vertical transformation. So this is vertically stretched. You can say by 16. So we're going to include that with our story problems. And you have that plus 80. So, and translated 80 units up. Okay, so if you need to add something, go ahead and do that. And then I'm going to draw a little representation here of what is happening, and then I'm going to squeeze it in over here as well. So you have this object that's being dropped from your platform. Okay, so you know that you have your x, which is the seconds, and then your h of x is going to be the height. The height that it's being dropped from is 80 feet. So if this is the platform, you can just think of, oh, this object is being dropped. Okay, and it goes like this until it hits the ground. This part isn't going to be there. This is your ground level. Okay, it forms a parabola. It's just that this part here doesn't matter in context of the situation. Sorry, I guess that's kind of hard to see. Yes, like the basketball yesterday that was on Google. No, I think they changed it to some kind of chemistry today. So for this one, we're going to talk about what's happening with the parabola, and you can use this example to help you when you're doing the homework problems. So what they want you to mention is the way that the parabola opens, and anytime it's a negative, the parabola is going to open downward. So that's what we're going to start with. The parabola opens downward. So and they want you to mention that because when this opens downward, that means this point here is a maximum. Remember we talked about maxima and minima? Okay, so the parabola opens downward, so there's a maximum, and this is what we're going to put in context. So h of x represents the height, so we're going to say, so there's a maximum height represented by the vertex. Okay, so the maximum is going to be the vertex. It is the highest point of your parabola. You are not going to have to mention the 16 there. Okay, we did talk about how the negative is what makes it open downward. That's going to be a maximum. That's enough for that. And then you're just going to say what that plus 80 represents. So we're just going to say the translation of 80 units up represents the initial height of 80 feet. Okay, so in this case, your vertex is your initial height. For problems like this, that is going to be standard. And I'm just drawing the same thing that I drew over here. I'm just making it a little bit smaller. Okay, so you have your max value here. You have this part of the parabola. You're describing that. You're not worrying about that other side. And this is here at 80. Okay? And you can follow that for any time you're doing the x squared. All right, and then the last thing we're going to do today is write an equation for each function. We did a little bit of this yesterday, but we're going to expand this today. Okay, there's going to be a few extra things. Okay, for A is a linear function. So you're not necessarily going to have to show work when you do this on your own. Anytime you have a linear equation, we want to write it in the form y equals mx plus b, where we're finding the slope and where we're finding the y-intercept. That's what you're going to have to plug in there. Okay, so I'll give you a minute, get a head start on me on that. You want to give it a go? Okay, I would start at my y-intercept, so that's going to be pretty simple for you to find on your graph. 1, 2, 3, 4, 5. Okay, and then when you are trying to find your slope, remember you can use the rise over the run. So I just try to find another point that's exactly at those corners there. So I can go down 1, 2, and then over 1. Okay, so if you're going 2 down, it's a -2. If you're going 1 to the right, it's a +1. So your slope is going to be -2. So your final answer is y equals -2x plus 5. Okay, if your line is going down, then we know we should have a negative slope. So even if you aren't sure about like the down and the right, you can get the 2/1 and then put the negative on to match the direction of the line. That is perfectly fine. Do you guys remember what the slope is if it's a vertical line and if it's horizontal? One of them 0, one of them is undefined. Do you guys remember which is which? The horizontal line is? It is 0. You want to know how I remember? You can make a Z for 0. Oh, how dare you roll your eyes in the back of your head. And then this would be undefined. Because you can make the U. Okay. All right. Now for B, you have the absolute value, which, like I said, we did some of this yesterday, but we did not talk about how the vertical stretches and compressions can affect that, and today we are. Okay, so if you have the absolute value, we are going to use the equation from yesterday, but we're going to add a little something to it. So we have f of x equals, and then in front of the absolute value, I just want you to put the letter a. So it's x minus h in the absolute value plus k. So yesterday when we did this, our a value was 1. We didn't have to worry about that. Now we're going to pay special attention to it when we are solving these problems. The first thing you're going to want to do is find your vertex. The vertex is just the highest or the lowest point. It's that point in the middle. Okay, it's symmetric about that point. So I'm going to go over 1, 2, 3, up 1, 2. So my vertex is 3, 2. Do you guys remember what variables the vertex goes in for? H and K. Good. So this is H, this is K. Okay, so once you do that, you're going to plug that into your equation. So it's f of x equals, and we're not plugging in for a at this point. When I plug this in for h, it's minus 3, because I have the minus here, that's positive, and then I have plus 2. Okay? In order to find the a value, all you have to do is find the slope of one of those lines. Okay, so you're going to find the slope that is equal to your a value. Okay, you're going to find the slope, and that is equal to your a value. We're going to talk about that in a moment. So do you guys see how they have this point marked off for you here? Okay, we're going to do the rise over the run. Okay, and we're just going to count. So this would be 1, 2, 3, 4, 5. Okay, and then it's going to be 1 unit over. We're not going to worry about the up and down at this point because you have two sides to the absolute value. So can you see on this side it's going down, it would be -5, but this side is +5. Okay, what determines whether it's a negative or positive is the way that the graph opens. Okay, so your A value is going to be positive if it opens up. And it will be negative if the V shape opens downward. So all you have to do is apply that to your graph. So once you find this, if this is opening down, it would be -5 that you put in front. If it's opening upward, which it is, you're going to keep the positive value. Okay, so this is f of x equals 5. And then you have x minus 3 plus 2. Okay, so when you're doing this, I should be able to see like what you plugged in for your vertex here. Like this part, do not write in your book. So you can just have like this for your work there. Okay, so there might not be a ton of work with that, but you should be showing your final answer and then maybe you're writing your slope. All right, for part C, this is a quadratic equation, which we also have an equation from yesterday. But just like we did with this one, how we added the A in front, we're going to do the same thing for that quadratic. Okay, do you need any more time with this? Okay, so for your quadratic, it's f of x equals, and then we're going to put the A in front there, and then x minus h squared plus k. Right, so you will need to know that equation for your quiz. These two equations are pretty much the same. The only difference is this one is parentheses squared, and the other one is the absolute value. Okay, so just like we did last time, the first thing we're going to do is we're going to find the vertex. So we're going to pay attention to our scale. So this is -2, -4, -6. This looks like it's right at what? -5 on the y. So my second part is going to be -5. And then this looks like it's in between 0 and -2. So my x value is going to be -1. Okay, again, we're going to be plugging those in for h and k into our equation. Okay, so go ahead and do that. Plug those in for h and k. Every other variable is going to stay the same. And remember, when you have that minus and negative, it is just going to turn into a plus. So it's fine if you have that just at your first step. F of x equals minus -1 is +1, and then this is just -5 on the outside. Okay, now your second step, and you are going to have to show work for this. So anytime you have a quadratic, you're going to have work that goes with it. What you're going to do is you're going to find a point on the parabola. Okay, you're going to find a point on the parabola, and you are going to plug that in for x and y. Okay, so you're going to have to show your work for when you are finding your point and plugging that in for x and y. So it can be any point that is on the parabola. And there's actually a couple of them on there that are great points. And then once you plug those in, you are going to solve for A. Okay, so this looks like it's a good point on the parabola. This is another one. When I say good point, I mean we're going to try to plug in whole numbers to make it as easy as possible. So this point here would be what? 0, -7. Okay, and then this is -2, -7. So either of those are going to work. You can choose whatever you want. Whatever you choose, you're just going to show me what you're plugging in. Okay, so do show me what you're plugging in so I know that you've chosen a good point there. And remember, y is the output. So in this equation, your y value is what? Because I don't have y there, so what am I plugging it in for? F of x. So f of x and y are the same thing. Okay, so I'm going to have -7 equals, my a stays the same. Instead of x, I'm going to plug in 0. So I have 0 plus 1 squared minus 5. And then we're going to solve that for a. Okay, I want you to try to solve that for a. Make sure you use your order of operations, right? Do what's in parentheses first. Then you're going to do the exponent. Then you would do multiplication or division. Then you're going to add or subtract. Okay, so do we have parentheses? Do we have parentheses up there where we got to simplify something?
No.
Yes, 0 plus 1. What's 0 plus 1? 1. Okay, and I like to do this at one time. So after that, before you multiply, remember you have to do that squared. 1 squared is just 1. Okay, if it's 1, 1 times a is just a. You can write a or you can write 1a. Okay, but you can't combine those first. Okay, you have to do this, then squared, then multiply. Then your final step is just to add 5 to both sides. Okay, and then once you have that, you can put it all together. So your f of x is going to equal -2, which it should make sense to you that this is a negative because it is opening downward. Okay, so it should be a negative answer there. Okay, and I'm just going to show you, you do not have to write this down. I just want to show you if you were to use -2, -7, the same thing would happen here. You'd have -2 plus 1 squared minus 5. What's -2 plus 1? 1. -1. And -1 squared? 1. And then you see how you end up with the same equation? So you still add 5, you're still going to get -2. Okay, so as long as you choose a point that is on the parabola, okay, it will give you the right a value. Okay, so the quadratic is going to be, you are going to have to show work for that. Okay, your linear and your absolute value is going to have minimal to no work. Okay, all right, so I'm going to give you some time to get going on your homework. Remember that we're doing a lot with the transformations, so this is going to help you memorize those so you're ready for your quiz on Friday.